Okay, so our goal today is to finish two topics, functions and quadratics. So let's start with the functions first. So what do you understand by function? Anyone can tell?
It's an equation.
Okay, yeah, I think that's the correct answer. So what is it is it's like a process. So the process which we use to take an input and give it an output, that's called the function. So here the process is, let's say x is the input. So if x is the input, y is the output. The process that's happening between the input and the output is called the function. So this arrow represents the function. So what's the function in this case? So like what's the equation? Yes. Anyone? Advait, do you know?
X square.
Yeah. So here function is the x squared. So that's okay. I hope you understood this. Like it's just a recap of what's a function. And then next is these are some important terms you need to remember when you're talking about functions. So the functions, as we saw, it's a rule or an algorithm that provides only one output for an input. So the domain is the range of input. So what can you input to that function so that it can give you an output? So that is called the domain. So basically it's the x values. And the range is the range of outputs, meaning the range of y values for the x values that are being produced. Understood?
Yes.
Okay. So next is one-to-one function. So for every input, there will be only one output. So this is a type of function where only one output is produced with only with one input. So example is y is equal to 5x plus 3. So if you input a number, let's say x is 0, so the y will only have an output of 3, nothing else. So many to function next, the many to function is basically for more than one input, there will be only one output. So basically the inputs can vary. So let here here is an example of y is equal to x squared. So if the x is negative 3 and 3, both gives the same output as 9. So that's called many to one. And one to many function is for every input there are many outputs. But this is like as we saw, this is not literally a function because the function rule is that it provides only one output. If it provides many output, it doesn't it doesn't consider it is not considered as a function. Yes, Advait, I saw you raising your hand.
Yeah, I just want to ask that is there like a reason why we don't consider one to many functions as, I mean, one to many mappings as functions?
So as yeah, you know that functions here the rule is the function only provides one output because any function you take, right, you need an input for only one output. You cannot like map to many outputs and then say this is the only input because that does in mathematics sense it doesn't make sense, right? Like in mathematics, mathematical reasoning because every number, let's say one, right? So if you take one and you map it with a function, let's say x squared minus one, it should only give zero. There won't be any other answer to it. But if it is a one to many, then there should be many outputs, which is not in the mathematical sense, it's not considered as a function. That's all.
Yeah, okay. Okay, makes sense, yeah.
Now we have the domain and range. So domain is, as we saw, it's the range of inputs or the range of x values that are being used. And the range is the range of outputs or the range of y values that has been produced. So let's just do an example practice question here. So find the domain of the function fx equals 3x plus 5. Can anyone answer?
Oh, they won't it be all real numbers?
Yeah, so you can take all the integers or any number from negative infinity to infinity. So that's the so in a linear equation, if they don't give you a specific domain, the domain generally is considered this negative infinity to infinity, any number between those.
So you write it as x is equal to all real numbers, right?
No, you write it in this way in inequality form. You write negative infinity less than x is greater than or equal to negative infinity or is less than or equal to infinity. So this is you need to write it in an inequality form because it's the range of values. You need to give a range, not a specific real number. You cannot put it in the set of real numbers.
Okay, then when do we use x is equal to all real numbers?
That is like maybe let's say quadratics. Quadratics can if there is a solution, real solution for it, then you can use that. But here it's only the domain. Mostly you use the real numbers for the range. So like you write f of x is to the range real numbers. So let's say if any integer is the domain, then the our range should be to the real number, any real number. It cannot be an imaginary number or something like that.
Okay, so the range of this function will also be f of x is equal to all real numbers.
Yeah, the range is this. This
Makes
is the
sense.
range, and
Yeah.
this is the domain.
Yeah,
Wait,
makes
sorry,
sense.
but you can also write negative infinity x infinity as x belongs to all real numbers. It's the same thing.
Okay, I'm not sure about that. I am not studied in that way. Okay, maybe you can. Because generally I used to write this, so I'm just talking from my perspective. If that is also correct, I think, yeah, maybe you can write it as this. Okay, so there's another practice question. You can find the range given the domain. You can just try it if anyone. Are you willing to try or should I just solve it?
Is it
I mean,
80
I can try.
is
Yeah.
it 80 is less than y is less than 255? Sorry, 245.
Yeah, so you understood the process, right? You substitute the ranges into the values into the
Yeah,
function and then find the outputs.
yeah.
Okay.
But I'm a bit confused about the sign of the inequalities. Would it be less than y? Would it be like so y is
You
greater than
just so what was the numbers you got? 80 and 245.
yeah,
So you just write it as 80 is since the inequality here is less than and not less than or
yeah,
equal to, you just follow the same the
same,
sign
yeah.
in the domain and then you write f of x then 245. Yeah,
We can
like
also
that.
write y, right?
No, because here it is defined as f of x. You cannot use the value y.
Oh,
If you
all
only
right,
define it to y, then only you can use it.
all right.
Okay, now some function notations. So you know these. This is the general one. So you use this for mostly f of x. This is also another alternative you can use. So it is f to the x, and then you can write the arrow symbol and then write the function. So this one is the inverse of f of any function. So the inverse of a function we will cover it in the next slide, in the upcoming slides. And then this is called the composite function. Composite. So even we will cover this in the next slides. This is inverse. Okay, so if it is f squared x, right? The thing is, if you have f squared x, it is not like you square whatever output you get. You need to see it as a composite function. So it's basically f of x. You got this? So this is the like sometimes it's tricky to understand this. You got it, right? Yeah.
Yeah, yeah,
Okay.
got it.
So now you can just try this question here, maybe.
Is it 125x square?
So like let me just try solve it also. F of 5x squared will be 5 times 5x squared squared 5 times 25x to the 4.
Yeah, it'll be
Plus,
125 x to the power 4, not squared.
yeah, it should be x to the power 4. You need
Yeah,
to,
yeah,
you
yeah.
need to,
I know, I know. I just missed the Excel.
yeah, just be careful in that. Okay, so magnitude of a function. So magnitude is a scalar value of any function's output. So if you get even a negative number as an output, so let's say if like negative 2, the magnitude of this will be 2 only. You just take the value of the output and not the sign of. So it is denoted by this symbol. So this means the magnitude and whatever is inside. So the f of x is inside, then that is the magnitude. Got
Wait, so
it?
you can get questions like this?
Yeah, you can. So like this is one of the topics, right? So you can get questions based on this.
Okay.
They will combine all the concepts together. If they ask in a functions question, right? They will combine all the concepts together. So that's you need to like apply all the concepts to just one question with the different parts or something like that. So mostly it will be
Okay,
like
I've never seen a question like this. I don't know.
it might come. Yeah, yeah. I'm not sure, but I just saw the topic name in the syllabus, so I just took it.
Okay, okay. It's fine. Yeah, yeah, makes sense.
So I can just try this question here also, practice question.
Is it 322?
No, one second. If I'll just write this maybe, and it also solve it. I don't have the.
Yeah, it's 322.
Okay, straight. Okay. Um. Okay. Now let's move on to the inverse of the function. So as we saw, the inverse is denoted by f in negative to the negative one of x. So what is an inverse in simple terms is the domain and range of a function, let's say f of x, right? The domain and range of the function is altered to be the domain and range of the original function. So it's interchange. So the domain of f of x, basically domain of f of x is the range of f inverse x. And the range of f of x is the domain of f inverse. Domain f inverse. You got this, right?
Yeah.
So now what this results is it gives the inverse of the function. Sorry, one second. Yeah. So and then this is a very key rule to remember. Only one-to-one functions have inverse, not like one to many and many to one doesn't have, because for every input, there's only one output for one-to-one functions. So if you want to alter the domain and range, right, it should be only a particular value. You cannot have set of values which you can uh, interchange. So that's the key point here. And then when you're drawing the graphs or sketching the graphs of functions and the inverse of the function, you need to remember that the function and the inverse reflects along the line x is to y. As you can see here, f of x is for I have given 5x plus 1. which is reflecting upon the y equals to x, which is x minus 1 over 5. Understood?
Yeah.
And you can just try this out. I'll just try it also.
Is it 1.8?
One six. Y equals to 10x plus. You know how to like change it to the inverse, right? Like you set
Yeah,
the function
one
as y and then you can just make the subject as x.
Yeah, it would be 1.8.
Okay, yeah, 118 by 10, then it's 1.8. Okay, now composite functions. So it includes two or more functions combined in this order. So it should be in an order, in a particular order. So if it is like two functions, let's say f, g, x, you need to start from the interior. So the interior is gx. So you substitute the function of gx into it. Then substitute the whatever you get inside. So here, let me just write it. So f of x, since it's 10x plus 2, if it is fg10, right? Sorry, fg10, you write f g of 10. So what's the value of 10 in gx? 10 squared is 105.
5, yeah.
And then you substitute this to the function of f of x. So 105 and then
1052.
plus 2. 1052. Got it? So the key
Yep.
here is only the order. You need to see which order it is coming from. G or fx or fgx, whatever it is. So we are done with functions. Any doubts before we move on to next chapter? Any doubts? Yes. Okay.
No.
Okay. Advait, what about
No, I don't have a doubt till now.
you? Okay. Then we can move on to quadratic functions. So the first concept of quadratic functions is maximum and minimum. So there are three methods you can use basically to find the maximum and minimum, either by completing the square, differentiation, or symmetry. So a general way of writing any quadratic functions is f of x, ax squared plus bx plus c. You know this form, right? So this is the generalized form of any quadratic function.
Yeah.
So let's let's go with the first one, completing the square. So here is an example. So for f of x equals to x squared plus 4x minus 5, you could find the minimum point, coordinates of the minimum point.
After a question, which
Yeah.
method do you think is like the best in each case? Like, I've done differentiation in my school, but
Yeah.
do you think completing the square or symmetry would work? I've never actually heard of the symmetry method, so I'm not
Okay.
aware.
So what is the okay, whichever is convenient for you. Basically, I would just tell that because it depends on the speed you finish it or you the accuracy you do it in. So like if you're very convenient with differentiation, you can just go with that. So I'll just show you all the three ways here, maybe first.
Yeah. I also,
So
for the
yeah,
vertex, isn't there a formula as minus b by 2a for vertex? Can't I use that? Because it's quadratic, so there's only one point, right? So
yeah,
it's
you can use that also if you want. But yeah, I find these three like because there is also for marks for the solving or the steps, right? So I think this is more convenient than using the formula because I don't think the formula is included in the syllabus.
oh, okay. Okay,
Like
all
for
right.
the latest syllabus, I don't think it is there. So
Right,
the
I get you.
completing the square, right? So first you do as such, you just complete the square here, 2x square plus 4x minus 5. So which is you take the 2 out, and this becomes x square plus 4 2x minus 5 by 2, and then you do the completing the square for this. So x plus 1 squared minus 1 squared minus 5 by 2. Then you can write this as 2 times uh, x plus 1 squared minus 1 minus 5 by 2 would be minus 7 by 2. So here you got this as the final answer. So what is the minimum point is you take this part. So this is the you have x plus 1 squared minus 7 by 2, right? So the minimum point will have the coordinates of 1 and 7 by 2. So this 1 you just this is the x coordinate. So x coordinate, okay, I'll just use a different colors. X coordinate is 1 or negative 1, I'm not sure. It should be negative 1, right? We need to inverse the sign. Ananya, can you help me with this? I think I forgot how to write the coordinates.
So basically, after you separate out the two, right?
Yeah,
You need to so the two is multiplying everything inside the brackets.
yeah.
But you can't write it like that. You need to write two times. So wait, open it up again.
Open it up.
No, as in like
Okay, 2 times x plus 1 squared, then minus 7 by 2, right?
x
So
squared.
you're telling to expand it again.
Yeah. So minus 7. And now the formula is the the shift within the x, so it's x plus 1, right? So the x coordinate would be minus 1 comma minus 7, because the general formula of writing the
Okay,
minimum
yeah.
coordinates is a times x minus b whole square minus plus c, where b comma c are the coordinates.
Okay. Yeah.
Also, for the other person's question about the minus b over 2a, as long as it's a quadratic function, you can use that. It's fine.
It's in the
Okay.
syllabus, right?
Yeah, because it's
Okay.
basically the expansion of, the big quadratic formula,
Got it.
minus plus minus b squared minus 4ac over 2a.
So minus b by 2a, that gives me the x value or the y value?
Um, that gives you the x value.
And won't the coordinates for this be minus 1 comma 7? Because if you're inversing, it'll become minus 1 and then minus bracket minus 7.
Um, but I didn't expand it. I'm assuming this is correct, minus 7 over 2.
I think you should not expand it. I'm not sure. I forgot. Maybe it's 7 by 2. Because when you do it in the generalized form, right, it won't be expanded.
No, you definitely can't write it as 2 multiplied by everything.
Yeah, that's what. So it should be negative 1, negative 7 by 2.
Yeah. No, not 7 by 2.
Oh, okay. Only
Wait, what's
7.
the symmetry method that you've written there?
It's
Yeah,
negative 1,
next is.
negative 7.
Okay, so negative 1, negative 7. Okay, I think you understood, right? Okay, next we will just move on to the differentiation method. So
Wait,
differentiation,
hello.
yeah,
Yeah, no, I just wanted to ask like what symmetry was.
yeah, I will explain that in the next round. after differentiation. If you understood differentiation, we can move on to the symmetry.
Yeah, I think we can
Okay,
move on.
okay, fine.
Symmetry. Okay, so symmetry, right? Any quadratic equation, when draw it, when you draw it out, you will get a curve like this or the curve on top. So since this is a positive, the x squared is positive. Sorry. So if the x squared is positive, it is going to be a curve like this, and then the minimum point will be here. Okay. So the symmetry, where you can see the symmetry is when you divide the curve in two parts between from the minimum point. So if you draw a vertical from the minimum passing through the minimum point, the curve will be divided into two equal portions. Understood?
Yeah,
So what happened? So this is, let's say, so this is the midpoint of the whole curve. So this part is going to be the turning point, and this will be the midpoint of this whole segment from the start of the root to this root. Got it?
can you say that though? Like,
So you
can
have
you
two
say
roots
that?
for a quadratic equation. So you have two roots, right? Two roots for any quadratic equation. So what happens is, since this is cutting it into equal portions, the center of this whole line segment will be the midpoint. So for these 2 points, this is the midpoint. So this is the midpoint of the points A and B. Let's say if A and B, M is the midpoint of A and B. Got it? Or should I repeat it again?
I've got it.
So since this is the midpoint, you can find these two roots with by solving the equation equal to 0. And if you after you get the two roots, you can find the midpoint using the coordinates of the two roots, because the coordinates will be 0. Sorry. So the coordinates would be some x1 value comma 0. This is x2 value comma 0, and the midpoint would be x2 plus x1 by 2 comma 0.
Yeah, differentiation feels simpler. Right.
So now this is the x value of the point. So this is the x value of the point here, because it is the vertical line, so the x remains the same. Got it?
Yeah,
So since this is the vertical line and the x remains the same, x equals to x1 plus x2 by 2. This point also will have the x coordinate as x1 plus x2 by 2. So then you can substitute whatever you get the value of this into the equation to find the y. Got it?
Yeah,
So it depends. If you find this easier or differentiation, you can just go with the differentiation method if you find it easier. So like different students get the analogy differently. So yeah. So now let's go on to the concept of conditions. So there are some important conditions which you need to know, like for quadratics, using this determiner. You know this determiner is in the equation. So like the equation of to find the quadratic roots is negative b plus minus b square minus 4ac over 2a. So we will take only this. So this is called the determiner. So this, what does the determiner mean is, it determines the number of roots or it is intersections and all those things. So like the number of roots, if it is two distinct, it should be greater than zero. If it is equal, it should be equal to zero. If there are no real roots, then it is less than zero. Because here you can see that it's a square root. So whatever applies for what properties applies for square root, it's applied here also. So if it is greater than zero means this square root will be a positive number. So there will be two distinct real roots. And if it is equal to zero, then this whole thing will be negative b over 2a plus minus 0. And if it is no real roots, this will be a negative value, which is not, it's an imaginary number. It's not a real root.
Hello. Wait, I have a question.
Yeah.
So like these conditions, right? Is there a way to visualize them? Like, do you have to memorize them, or is there a way that you can make sense out of it?
Yeah, that's what I told you. The only reason you can tell is about the properties of square root. So square root, some positive number. So if it is a positive number, right? The answer will be a positive. So then you can understand that there should be minus b plus minus if the positive number is 2 over 2a, right? There are actually two roots here. You can visualize it like this. So plus minus b plus 2 over 2a is one root. Minus b minus 2 over 2a is another root. So there are two distinct real roots here.
Okay. Okay.
So if it is equal to 0, right? So it's the same thing as minus b over 2a. Yeah, I think we got this. This is the equation to find the minimum also. You can use this. And then if it is a negative, right? So if this is a negative number, then there will be no real roots because square root of negative is undefined.
Okay, and if you have like a real time question, like if you have a real question which asks you directly, uh, like
If it has
you
two
have an
distinct roots,
equation
or
and it's
like,
asking you to find real and equal roots,
yeah.
then can you do it by drawing the graph, or can you also do it with this method?
Are you asking like a proving question, or like they already say it is two equal roots?
I'm trying to ask a question like I can maybe show you because I don't think I remember exactly the question. I don't remember the exact
No, like
question.
just tell me the type of question. How is it going to tell
So
you
you
that it
have
all?
hmm, you
So
have a
it is.
question like k is equal to x square plus 3ax plus b, and it's asking you what are the possible values of k for which the equation has real and equal roots.
Wait, the k is equal to x square plus 3ax plus b.
Yeah, yeah.
Here you
So
have
what
three
values
terms
of k?
to tell if it is equal roots. So k should be equal to. So since this is equal roots, right? So you told it is equal roots. Then b square minus 4ac should be 0. So b squared is 3a squared minus 4 times 1 times b equals to 0. But the question is incomplete here, right? How will
Okay.
you say that you can find the value of k? There are three variables.
Yeah, so I
At
think
least they give you the equation, they give you a correct equation, and then they ask you to find the ranges of k, or they ask you to, they already tell you if it is distinct, equal, or no real. Then you need to use these three equations to find the range. So there are two types. One is they tell you or they ask you the values or the range of values that is applicable to the equation. Got it?
let me see once I find it, I can WhatsApp you and
Yeah.
you can
Maybe you can
explain.
just send it over the group. I'll just compile that also.
Yeah. that works.
Okay, now we will move on to the intersection of lines and quadratic curves, straight lines and quadratic curves. So the analogy is the same. So if there are 2 points which are intersecting, the b square minus 4ac is greater than 0. If it is only 1 point, it should be equal to 0, because you can see in a quadratic curve, there's only one minimum point or one maximum point. So when you draw the tangent for a quadratic curve, it is always a horizontal line. So that's why it's equal. This is equal to 0. Got it?
Yeah, I'm a bit confused in this. It's intersection of line and quadratic curve. So I'll have to use the b square minus 4ac
So
for the
let's
correct.
Okay,
Yeah.
let me just draw everything. Maybe
So
that
can we
might
do a
be.
question? I don't get the 2 points intersection thing. Because shouldn't we equate the quadratic curve with the line?
You
I
want an
don't get.
example question?
Yeah, I don't get why we have to use b square minus 4ac here.
Okay. Okay, say here we have this. This is the straight line equation, and this is the quadratic equation. And they tell you both these line and the curve intersect at 2 points. This is just an hypothetical question, right? Because I have not taken it from any past paper. Intersect at 2 points. If they tell you it is intersecting at 2 points, and they ask you to find the coordinates of these 2 points, so what is will be your strategy to
I'll
the
equate them.
steps?
I'll equate them. 5x square minus 4x plus 1 is equal to 5x plus 3. Then I'll move it all to one side and then I'll solve the quadratic.
Yeah, so you equate both, and then you'll get another quadratic. So here you'll get um, 5x squared minus 4x plus 1 equals to 5x plus 3. So 5x squared minus 9x minus 2 equals to 0. After this, since they told you it intersects at two distinct points, right? You write it based on this. So this is the B.
Oh,
So
I
this
think I
is
get it.
B. This is A, and this is C.
So in a
You
question, normally they'll
equate,
give
yeah. Then you inequate to this, and then find the range of x values
so they'll probably
based
give
on
you like
what
how
is.
many, they give us two equations and it'll be like how many times do these two lines intersect? This line and this
Yeah,
whatever intersect, and then you have to do this instead of
yeah,
solving.
yeah. That's how you do it.
Okay, all right, I
So
get
first
it.
step is to equate, then you substitute, then you find the range.
Right, right, okay, all right.
Okay, I found a question. Maybe that you could solve.
Okay, I think Ananya will be doing the doubt clearing. Maybe after the revision, we will move on to that.
Okay.
So now the last topic here will be solving the quadratics, finding the roots. There are three methods, as you know: factorizing, then squaring, and then the formula method. So there are three methods. So you know how the factorization works, right? You split the middle term into two terms, then make common in factorize both the common terms, and then you get two things like x plus something and x plus something like that. And then you find it based on the thing. You know the factorizing, right? So should I need to go through it, or you want to try this question?
I get it, I get it.
Yeah.
It'll be -2 and -3, right?
Yeah. So then I'll just skip that. Now completing the square. So you just do the completion of the square. Shouldn't so x square plus 5x plus 6. You can do it. x plus 5 by 2 whole squared plus minus 5 by 2 whole squared plus 6. And then you solve it, you make
Wait,
these two go here and then square root,
I,
then you find it.
I don't get why it's 5 by 2 here. Shouldn't it be like, what are we factoring out for it to become 5 by 2?
So here it's already a fact. You cannot factorize anything out because x squared is
Oh,
already 1.
I got it, I got it.
So you need to just divide the middle term by 2, 5 by 2. So that's how you complete the square here. Got it?
Yeah, I got it.
So if there is something like, let's say, 2x squared, then you factor out the 2, then do the completing the square afterwards.
Yeah, I got it.
So then formula method, this is the formula you need to remember. I think this will also be in the formula sheet in the
Yeah,
exam paper. So you just substitute the A, B, C. So A here is 1, B is 5, and C is 6. Substitute it and you will get the x values, two x values.
yeah.
Okay, now sketching the quadratic curves. So when you want to sketch any quadratic, there are three main points you need to know. So one is the roots. So which root is it? So like the solution of the two roots, and then the minimum point. So the if you have these three, you can just sketch and the y-intercept. Sorry, also the
The minimum,
y-intercept.
minimum or maximum, right? The vertex.
Yeah, well, depending on the equation given, if it is negative x squared, then it should be maximum. Then x, if it's positive, then it's a minimum.
Right, right.
So here you can find the y-intercept is 6, and you found it these 2 points, -2, -3, -2, and then draw it. Just follow the lines. That's all. Can extend it also here. Yeah. So just make sure this midpoint or the minimum point or the maximum point is accurate and mentioned. So here
The
it's
vertex, yeah, the vertex is minus 5 by 2, right? No, yeah,
yeah, it should be -5 by 2. Yeah,
yeah.
and some y value which will you get after substituting it in.
Yeah, we can substitute for that.
Okay, I think I'm done now. I'll just compile those questions which you have sent. Have you sent anything, Nainik, or you?
No, I'm quite thorough with this topic.
Wait,
Okay.
I've sent some my questions to Ananya also. Like and I also have some conceptual questions. So
You can send any. It doesn't need to
Yeah,
be
I think you can send it in the group or directly because I'll compile it here if it's a past paper question.
like any past
Okay.
paper.
Sorry?
You can send any past paper questions you have doubts and it doesn't be for this.
Yeah, that should also work.
If you don't mind me asking, are you guys in A levels or
I just finished IB.
you termed it IB?
Yeah, they just ended Friday.
Yeah, I just finished this IGCSE in 2025, so I'm going to A levels next year.
And you're starting like Ananya is starting IB or A levels?
No, I'm gonna go to
She
university.
finished.
Yeah,
Yeah, she
I thought
finished
I
IB.
misheard you. IB. Oh,
Sorry?
I thought I heard IGCSE instead of IB.
Oh no. I finished